Okay, so this method is definitely way easier and much shorter than doing integration by parts the normal way, where you have to pick your u, your v, your u, dv, and so on. So the way it works is you write a d here, and then you're going to put an I over here. So this is the example we're going to use to show how to use the DI method. So you pick your U and dV the same way that you would when you were using integration by parts the normal way. So as you know, x cubed is going to be your U. So we have x cubed here, and then we have e to the power of 2x. So the d here stands for differentiate, I stands for integrate. So what you're going to do is you are going to differentiate over here. So you differentiate, you get 3x squared, differentiate again, you get 6x, differentiate again, you get 6, and then you will get 0. When you get to 0, you stop. That is one of the times that you do stop. In the next example, we'll see what are the other times that you do stop and don't just keep differentiating forever. And then here we integrate, we'll have half e to the power of 2x, then 1 over 4 e to the power, that looks like a 9. Then 1 over 4 e to the power of 2x, then 1 over 8 e to the power of 2x, and then 1 over 16 e to the power of 2x. Now over here on this side, you're just going to alternate between pluses and minus. So you put a plus, a minus, a plus, a minus, and a plus, and you carry on as long as you've differentiated and integrated. Then you draw arrows like so. Okay, so you skip this one. The first one goes to the second one to the third one, and so on until you get to the last one. And then with your last row, you draw a horizontal arrow. So your diagonal arrows like these, those are going to be solutions, and then horizontal arrows, that is what you're going to integrate. Okay, so the integral of this x cubed e to the power of 2x, I can write it over here. The integral of x cubed e to the power of 2x dx, this is equal to, you take the plus and then you multiply like this. So you have a half x cubed e to the power of 2x, and then you have a minus, multiply like that. So it's negative 3 times a quarter is 3 over 4 x squared e to the power of 2x, and then the plus, you multiply 6 times 1 over 8, that is 3 over 4 x e to the power of 2x, and then the next one is minus 6 over 16, that is 3 over 8, so it's minus 3 over 8, then e to the power of 2x, and then we said with the last horizontal arrow you add and you integrate. So 0 times this is just 0 dx, and we know that the integral of 0 is a constant. So your final answer will be a half x cubed e to the power of 2x minus 3 over 4 x squared e to the power of 2x plus 3 over 4x e to the power of 2x minus 3 over 8 e to the power of 2x plus the integral of 0, which is c. Okay, here's a second example. We want to use the DI method to integrate this. So again, we will write d and we'll write I over there. Now, as you know, when you have exponential and trigonometric functions, it doesn't really matter which one is your d and which one is your I. That means which one you're going to differentiate, which one you're going to integrate. So the choice is yours. I prefer to have my sine x as the function that I'm going to differentiate, and then e to the power of x as the function that I will integrate. You can swap them, you'll still get the same answer, so the choice is really yours. So we know already that the D stands for differentiate, I stands for integrate, so we just differentiate. So here, the derivative of sine is cos x. The integral of e to the power of x is just e to the power of x. Then the derivative of cos x, this is minus sine x, and then the integral here is e to the power of x. Now you can see we're going to get into a loop because none of these derivatives ever go to 0, and here we'll just keep integrating forever. So how do you know when to stop? You stop when you have a constant multiple of what you started with, because you know that if I multiply with our last row, we're going to draw an arrow like that. Wherever we stop, we're always going to draw a horizontal arrow, and we'll have to integrate what we have on the last row if we multiply them. And if what you have here is a multiple of this, a constant multiple, that means the only difference between what you have here, if I were to multiply, is a number. So you see, if I were to multiply this and this, I'd get negative e to the power of x sine x. It is exactly this except for the negative one that's multiplying. So that tells you when to stop, okay? So whenever I get a constant multiple of what I'm supposed to integrate in the question, that tells me to stop. Otherwise, I would go on forever because this derivative never goes to 0. Okay, so I'm going to stop there, and then I put my plus minus as usual. So I start with a plus always, then a minus, and then a plus. Then I draw my arrow first with the second one, second with the third one, and in the last row, it is horizontal. And then we write the integral of e to the power of x sine x dx. This is equal to positive e to the power of x times sine x, and then minus e to the power of x times cos x, and then plus the integral of negative, because of this negative here, e to the power of x sine x dx. Okay, so we work this out, e to the power of x sine x minus e to the power of x cos x minus the integral of e to the power of x sine x dx. Now, this is exactly the same as what we have on this side, so we can collect them together on the same side. So when it goes to this side, it'll become positive. So I'll have e to the power of x sine x dx plus the integral of e to the power of x sine x dx. This is e to the power of x sine x minus e to the power of x cos x. Okay, and then these two, because they're exactly the same, that means I have 2, the integral of e to the power of x sine x dx. This is equal to e to the power of x sine x minus e to the power of x cos x. And remember the question, we're only looking for the integral of e to the power of x sine x. So what we do is divide both sides by 2. And after we've divided both sides by 2, then we can add our constant of integration. So the integral of e to the power of x sine x dx, this is equal to a half e to the power of x sine x minus a half e to the power of x cos x, and then I add my constant of integration. The constant of integration doesn't need to be written as c over 2 because that is still just a constant which you can just write as c. So this is a much shorter method for integration. Feel free to use much shorter method for integration by parts, so feel free to use it.